Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part B. This is Lesson 8, and we're going to talk about the area of a sector. So just a quick review here. A sector of a circle is just a part of a circle bounded by two radii and the intercepted arc. So we've got these two radii right here, SR and ST, and then we've got the arc that they intersect. And so this would be the sector that we're talking about. This is also a sector. It's a bigger sector, but we're focusing on this shaded sector. So let's take a look at how we find the area of that sector. So a sector is a fractional part of the circle's area. So just like we did when we did arc length, we're going to find a portion using a fraction with the area formula. So here is that same sector that we just looked at. So if we wanted to find the area of this sector, sector ABC, with a radius of r, we're going to apply this formula. So we've got the measure of arc AC right here. So that, remember, that's the same as the central angle. So we got to know that central angle divided by 360 times pi times radius squared. So if you can recognize this right away, that is the area of a circle formula that we've talked about in previous lessons. And just like arc length, this is the fractional part of the circle. So that'll give you the fraction. So like 1/4, 1/3, whatever the fractional part is. So let's look at an example of how this is applied. So here is a circle. It has a sector bound by ABC with a central angle of 50 degrees and a radius of 8 yards. So if we wanted to find the area of that sector, we're going to apply our formula. So we're going to find the measure of arc AC, divide that by 360 and multiply by pi r squared. Now again, remember, unless you are told to do so, you're going to leave the answers as exact answers with pi as a symbol, not substituting 3.14 or any other thing. Only substitute something for pi when you are asked to do so. So let's take a look. We're going to substitute here. Our central angle is 50 degrees, so that means our arc is also 50 degrees. We're going to divide by 360 times pi, and then our radius is 8 yards, so we'll substitute in 8. So we're going to apply our exponent there to get 64. And now, this is where you need to make sure you have your calculator. Calculators are very important for things such as this. What we're going to do here is we're going to multiply anything in the numerator. So 50 and then 64. Because 64 doesn't have a fraction, it's automatically a numerator. So we're just going to multiply 50 times 64. So pull out your calculator. 50 times 64. There you go. We got 3,200. So we'll end up with the area of a sector is 3,200 over 360. And now pull that calculator back out and let's reduce this fraction and see what we get. So if you have a TI-84 or 83, it's the same process. We're going to divide this 3,200 divided by 360. And this might come out to be a whole number. I don't know, but it doesn't matter. We're going to hit math right there. And that first option will turn our answer into a fraction that is reduced. So we're going to hit that and then hit enter. And look at that. We've got 80 over 9 as a reduced fraction. So the area of this sector is 80 over 9 times pi yards squared. And that is the exact answer. Remember, we don't estimate using pi unless we are told to do so. Let's take a look at one more example here. So here is another sector. So again, the sector AC is what we're looking for. We've got a central angle of 140 and a radius of 6. Now let's see what we're asked to do here. So we're going to find the area of this sector. And this time we're going to use pi as approximately 22 over 7. So we're going to use an estimate for pi, but we're going to use a very specific one. So make sure you use this estimate. Don't use a different estimate. You won't be given credit for using that instead of using the one that you're asked to use. So we're going to substitute into our formula. Measure of AC will be 140 degrees. R is 6, so we're going to substitute those values in along with our estimate for pi. So we're going to apply the exponent to 6 squared. That's going to give us 36. And now again, pull that graphing calculator back out. And we're going to multiply these things right here. 140 times 22 times 36. That's a pretty big number, but don't worry about it. You got a calculator, so big numbers shouldn't bother you with the calculator. So we've got 1,000 or 110,880, and same thing, 36 times 7 on the bottom, 360 times 7, excuse me, on the bottom. That'll give me 2520. Again, I want to use that calculator to help me reduce that. And then I think you're going to see the reason why we wanted you to use 22 over 7 here in just a second. So if we hit enter on that, look at that, we get a whole number, 44. So that means that this will have an area as approximately, and I didn't put my approximate symbols, I should have, approximately 44 miles squared. So that would be the area of that sector. So I hope this helps you with finding the area of a sector. If you still struggle with this content as you're doing your assignment, please let me know in a teacher message or make an appointment for a help session.